Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the infinite geometric series and exactly when adding up infinitely many terms actually gives a genuine, finite answer. Let's begin.
A geometric series, a plus a r plus a r squared plus a r cubed, and so on forever, only converges to a genuine finite sum when the absolute value of the common ratio r is strictly less than 1. If the magnitude of r is 1 or greater, the terms simply don't shrink toward 0, and the sum genuinely grows without bound, diverging instead. When this convergence condition, -1 less than r less than 1, is genuinely satisfied, the sum to infinity is given by the elegant formula, S infinity equals a divided by 1 minus r, where r is the first term. This formula is genuinely derived by taking the standard finite sum formula, Sn equals a times 1 minus r to the power n, all over 1 minus r, and letting n approach infinity, since r to the power n approaches 0 specifically when the magnitude of r is less than 1.
As a genuinely direct example, find the sum to infinity of 1 plus 1 half plus 1 quarter plus 1 eighth, and so on forever. Here equals 1 and r equals 1 half, both satisfying the convergence condition, so S infinity equals 1 divided by 1 minus 1 half, which equals 1 divided by 1 half, equals 2. A genuinely elegant, frequently tested application converts recurring decimals into fractions. Take 0.333 repeating forever. This can genuinely be written as an infinite geometric series 3/10 plus 3 over 100 plus 3 over 1000 and so on, with first term, a equals 3/10 and common ratio r equals 1/10, giving S infinity equals 3/10 divided by 1 minus 1/10, which equals 3/10 divided by 9/10, equals 1/3, exactly confirming that 0.3 repeating equals 1/3. A genuinely frequently tested JEE trap involves students applying the sum to infinity formula without first genuinely checking the convergence condition if a problem gives a common ratio with magnitude 1 or greater. There simply is no finite sum to infinity, and any answer computed by blindly plugging into the formula would be genuinely meaningless. Always verify -1 is less than r is less than 1 before proceeding. A genuinely useful prenatally tested variant involves the sum of an infinite geometric series where the terms themselves are functions of a variable, like x, or trigonometric functions like sine or cosine, some angle. In these cases the exact same convergence condition and formula apply directly, just treating the specific expression as the common ratio r. Also remember that for a genuinely infinite geometric series with all positive terms, the sum to infinity is always strictly larger than any individual partial sum, but the partial sums genuinely approach this infinite sum ever more closely as more terms are added. Let's recap. An infinite geometric series converges to a finite sum only when the magnitude of the common ratio is less than 1, and in that case, the sum to infinity is over 1 minus r. Recap. An infinite geometric series converges to a finite sum only PRP Morshambar Mekans Lumbor Umanoka Merapchas a common ratio is less than 1, and in that case, the sum to infinity is over 1 minus r. This formula elegantly converts recurring decimals into exact fractions, and the single most important exam habit is always checking the convergence condition before applying the formula, since a ratio of magnitude 1 or greater means no finite sum exists at all. That's the infinite geometric series. Keep the convergence condition and the sum to infinity formula sharp, and remember to always check before you calculate. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.